to explain about analysis and detection of autism spectrum disorder using machine learning techniques. Introduction. Autism is a neuro-based disorder which will affect the human brain from childhood to adulthood. And this disorder makes a person to laugh unnecessarily, no feeling of pain, unable to make eye contact, and many more disorders. 1 in 160 children around the world are estimated by the World Health Organization to have an autism spectrum disease. There is currently no known treatment for ASD. However, one solution is to slow down the disorder's progression. For this disease, individuals and their families' early diagnosis can be crucial to addressing the aforementioned concerns and enhancing the quality of life. Objective. The project aims to develop an effective method for the analysis and detection of autism spectrum disorder using the machine learning techniques. This disease has been characterized by various symptoms such as difficulty in social interaction, repetitive behavior, and impaired communication skills. The project aims to investigate the potential of machine learning algorithms including SVM, KNN, naive-Bayes, logistic regression, artificial neural network, and the convolutional neural network, and accurately identifying and classifying the individuals with the disorder. Requirements of the project are hardware requirements as well as software requirements. In hardware requirements, operating of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, we require Python IDEL of 3.7 version. Methodology. For execution of the project, we have designed 11 modules. In first module, we will be uploading the ASD dataset for the application purpose. In second module, which is pre-processing the dataset, in this module, we will read the entire data set and then replace missing values with 0 and convert all the non-numeric values to numeric by using label encoding algorithm. After pre-processing, we will split the dataset into train and test of 80% of data of train, 20% of test. And next, in third module, we will be running the SVM algorithm. In this module, the processed trained data will be input to the SVM algorithm to predict the model. And this model will be applied on 20% test data to compute SVM prediction accuracy. Similarly, we will be doing with the KNN algorithm, naive-Bayes, logistic regression, ANN, and CNN. In the ninth module, we will be predicting the unseen data, which is detect autism from test data. In the 10th module, we will be checking all the graphs of all the algorithms. In the 11th module, we will be checking the CNN training graph. Execution. For execution of this project, we will be opening the main code file. This is the main code folder. This is the data set. This is the main data set on which we are going to train the model. Next, this is the unseen data set. Using this data set, we will be predicting whether the person has disease or not. Next, this is the main code file which contains the Python script in it. And this is the run.bat file. Instead of executing the project in command line interface, we created the Windows bat file to execute the project. So double click on it for the execution. And this is the graphical user interface of this project. With this directly, we will be interacting with the program. So first click on the button Upload ASD dataset. By clicking on this button, we will be uploading the dataset. So select this dataset, click it on Open. The dataset is uploaded. On x-axis, we are having yes and no, which means the person has disease or not. On y-axis, we will be having the counts. This bar is representing the persons who all are not having the disease, and this bar is representing who all are having disease. Close it. Next, we will be pre-processing the data because there are null values as well as the string values in the data. The data is pre-processed here. After pre-processing, the data is split into train and test. Prior to the train and test split, there are 704 records. After train and test split, in train, we have 563 records. In test, we have 141 records. Next, we will be running the SVM algorithm. This is the confusion matrix of the SVM algorithm. This is the true negative. This is the true positive. This is the false positive. This is the false negative. So these are the scores for the metrics of SVM algorithm. Next, we will be running the KNN algorithm. Similarly, this is also the confusion matrix of KNN algorithm. And these are the scores for the KNN algorithm. Next, we will be running the naive Bayes algorithm. This is the confusion matrix for naive Bayes algorithm. And these are the scores for the naive Bayes algorithm. Next, we will be running the logistic regression algorithm. So this is the confusion matrix for logistic regression. And similarly, scores are for logistic. These are the scores for logistic regression. Next, we will be running ANN algorithm. So this is the confusion matrix for the ANN algorithm. Accordingly, these are the scores for ANN algorithm. Next, we will be running the CNN algorithm. So this is the confusion matrix for the CNN algorithm. And these are the scores for the metrics of CNN algorithm. Now we are going to run LSTM algorithm. So this is the confusion matrix of LSTM. And these are the scores of LSTM. Next, among all these models, which model has performed better? That will be used for predicting the test data, which is unseen data set. So click on the button, detect autism from test data. So we are selecting the test data, click it on open. Here the records are predicted. First record is predicted as autism disorder detected, which means the person has the disease. In second record, it is predicted as no autism disorder detected, which means the person has no disease. Next, we are going to compare all the graphs. When we compare the graph, on the x-axis we have the algorithm names, on y-axis we have the scores. So blue line representing the accuracy, orange F1 score, green precision, red recall, purple sensitivity, brown specificity. Among all the graphs, CNN is performing very well. Next, we are going to run CNN training graph. So this is the graph. This green line representing the accuracy, this orange line representing the loss, and the x-axis is the iterations or the epoch. Y-axis is the accuracy. Close this. Conclusion. The machine learning algorithm, specifically convolutional neural network, showed the potential for detecting autism spectrum disorder based on neuro-based symptoms. CNN achieved high accuracy among all the models. This indicates CNN can effectively differentiate between autism spectrum disorder and non-autism spectrum cases. In comparison, other algorithms such as SVM, KNN, naive Bayes, logistic regression, and artificial neural network also demonstrated reasonably with the high accuracy rates, varying levels of misclassification.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.